Hey guys, welcome to Easy Academy. Today we're going to be learning about the three different measures of central tendency in statistics. And the first one's going to be the mean. And as some of you guys might know already, the mean is essentially just the average of all the numbers in a data set. So for example, if this is our data set right here, we'd add up all these numbers together. 2 plus 3 is 5, 9, 15, 19, 22, 24, 29, 34, and 36. So it'd be 36 over the total number of numbers in the data set. So there are 10 numbers here, so we divide by 10, and we see that the average or the mean of the data set here is going to be 3.6. Now in statistics, there's also something called the trimmed mean, and the trimmed mean is essentially a more personalized mean of the data set. So for example, if you want to find a 10% trimmed mean, you would have to put the entire data set in the order from least to greatest. So here we'd have 2, 2, 2, 3, 3, 4, 4, 5, 5, and 6. And then we'd have to trim off 10% of the data sets from each side. So 10% of this data set would be 10% multiplied by the total number of numbers in the data set, which is 10. And we say that's equal to 1, which means that we have to trim off one number from each side. So we cross this out right here and we cross this out right here. We would have to find the mean of the numbers in between. So the mean of these numbers here. And that would be adding up to be 4, 7, 10, 14, 18, 28. So it would be 28 over the total number, which is going to be 8 numbers that we're finding the mean of. And then we can simplify this down to 14 over 4 or 7 over 2. And if we want to convert it to decimal form, it would be 3.5. So the trimmed mean of this data set would be 3.5, a 10% trimmed mean. Now, the second form of central tendency would be the median. And the median is essentially the center of the data set. So as we laid out already, every single data set from least to greatest here, we would just use this data set here and to find the median by finding the middle of the data set. So we'd have to cross out one on the left side, one on the right side, and keep on going until there are 1 or 2 numbers left. If there's 1 number left, then that number is your median. If there's 2 numbers left like there is here, you have to find the average of the 2 numbers there. So the average of 3 and 4 would be 3 plus 4 over 2, which is going to be 3.5. So the median of the data set would be 3.5, and the mean here would be 3.6. Now, the mode essentially is how many times a number occurs within a data set. So if we have this data set right here, the number that occurs the most here would be 2 because it occurs 3 different times here, and there are no other numbers that occur 3 more different times or occurs more than 3 different times. So the mode here would be 2. So one really important concept of the measure of central tendency is whether or not outliers would affect the measure of central tendency. So for example, if I added another data point right here of 100, would that drastically affect my mean, median, or mode? And if it doesn't affect the mean, median, or mode, then we say that form of central tendency would be resistant to outliers, but if it does affect it, it's not resistant. So the mean is essentially the average of every single number, which means we would have to incorporate the 100 into our calculations, which would probably skew our numbers. So we say that the mean is not resistant to outliers. Now, one exception though is going to be the trimmed mean, because as you remember before, the trimmed mean took off certain amounts of values from the smallest values from a data set and the largest values from a data set. So if we had a 10% trimmed mean, it is highly likely that we would be cutting off any outliers that are large values. So we would say the trimmed mean would be resistant to change or resistant to outliers. Now, the median is also very similar, except the median finds the actual center of the data set, and because it's going to be crossing off a lot of different numbers from the extreme polar sides of a data set, we would say that the median is going to be a resistant form of central tendency to outliers. Now, the mode is also the same because the mode is not going to be affected by outliers since outliers don't occur very often. So it's very unlikely that an outlier would suddenly become the new mode of a data set.